All right, so we meet again for this course, and let's see what we did in the last meeting. We did glance through the auxiliaries that are essential for printing. We also understood various isotherms which are applicable to different class of dyes like Langmuir, Freundlich and Nernst, and also learned that wet dyes and solubilized wet dyes are good for printing, and actually solubilized wet dyes can print protein fibers as well. And also learned that reactive dyes are good not only for cellulosics, but also protein fibers. In fact, we can spend a little more time here again just to recollect as to what can be done with reactive dyes. So, we continue with our journey, and we will consider more dyes and pigments which are used in the conventional printing system, which are likely to give good fastness properties after printing. So, reactive dyes we did talk about. So, we said this is one reactive group where you have 2 chlorine, and so this is called the dichlorotriazine type of reactive dye, but the chromophore is somewhere here, right. And this type of dye we thought is not good for printing because it is more reactive, and we would prefer such dyes which would not react at all, at least at room temperature. You have to take it to 60 degrees to 80 degrees before they fix. And so, one of the ways the same group was modified is that you have only one chlorine, and so you have monochlorotriazine group, similar dye, but this is the change that you make, and so this is sometimes known as hot brand dye as well, and so they are the ones which will be preferred for dyeing compared to the one which is on the top. All the dyes are water soluble, as we know, because of some groups like this. So, this is the solubilizing group. And so, they are water soluble, and so we will make paste in aqueous medium. So, initially, whether in dyeing or printing, we would like first the diffusion to take place inside the fiber, and then chemical bonding, which obviously we believe is a covalent bonding that will take place. So, this is true that we must make sure that this happens. So, there are other types of reactive groups also, like vinyl sulfone, and their conditions are also different of fixation. So, there are possibilities of using different reactive groups, but all of them should be such which give you an advantage in terms of reactivity being little low. So, if we again recall, the specific requirement for printing is that the temperature of printing or fixation should be high. Fastness, what we said, if everything has reacted covalently, the fastness will be the excellent fastness. There is no issue on that as far as the wash fastness is concerned. Light fastness depend on the chemical structure and not on the reaction alone. So, if most of us have found it difficult to believe that the reactive dyed and reactive printed fabrics actually give fastness less than 5, is because some of the dye does not react, but stays back. We did talk about substantivity versus reactivity. So, moderate reactivity is a good idea, not very high reactivity. So, all the molecules that you make will have moderate reactivity. Substantivity also towards the fiber should not be very high. because in case, particularly in the cellulosic case, if there are hydrolyzed dyes which are formed, because we are looking at reaction with the hydroxyl group of cellulose, and water also has the same situation. So, this can cause hydrolyzed dye if the conditions are as good as for reaction with cellulose, and therefore right, the problem is not of fixation alone, the problem is storage of the printing paste. The printing paste is made sometimes for almost a week, the main paste, and the dye is added maybe for the whole day, and so we keep printing, but we must make sure that while it is in the paste, it does not react. That is one of the important things. And obviously, we will be storing the paste at room temperature. So, highly reactive dye which will require less temperature to get fixed. Temperature is one of the important parameters which can be fixed to vary the time of fixation, etc. And so, that is not a good idea. As far as the dyeing is concerned, we do cold pad batch method, where the dye solution is prepared very quickly, all right, and then you pad, and then you pad with an alkali, and then you batch, all right. So, one has to take precautions. Once it is on the fiber and there is no water, not much water, then slowly it can get fixed at room temperature. But printing, the paste duration is large, so we do not prefer that kind of thing. Substantivity, as we said, would be low, relatively low. It is not that there should not be substantive at all, then it will not go to the fiber, although it is not an exhaust process. You take a screen or a block or whatever, you actually put it there wherever you want the dye to be there, and so dye cannot run away, and the concentrations are also high. And so, it is going to diffuse, but it should not be repelling, it should not be something like hydrophobic fiber versus a hydrophilic dye. So, that is not a good idea, but affinity should be there, but not very high substantivity. Like every time we wanted to do good fastness properties, we always wanted high substantivity, so that goes more towards the fiber. But here the mechanism of fixation is chemical bonding. So, even if it is, once it goes in and then gets fixed, then the wash fastness does not depend on whether it is substantive or it is not substantive, it will be fixed. That is the advantage in reactive dyes. Substrate, that what you said, cellulosic, cotton, viscose, rayon, no doubt, that is for basically reactive dyes initially were synthesized for these, but all these reactive dyes can dye very easily all protein fibers as also nylon. The end amino groups is good enough to be reacted and do not require alkaline medium. And if you do not require alkaline medium, hydroxyl group will not react, that is water will not react, and therefore you will have less hydrolyzed dye, and so for the protein fibers, pH being different is a much better option, and the reaction takes place. And if anything, any dye which is not reacted is not hydrolyzed also. So, this is what we just talked about, that pH for the protein and nylon are going to be neutral and little acidic, and so no hydrolyzed dye is going to be formed. So, that is the biggest advantage. So, we do have other type of dye which are called bifunctional. They are, from the dyeing purposes, they are known as high exhaust dyeing. So, they have two reactive groups. This reactive group is called vinyl sulfone, right. So, there are two reactive groups instead of one, and therefore, they are called bifunctional reactive dyes. So, you must appreciate here also there are two chlorines, but this is not called bifunctional dye. These chlorines are on the same reactive group. So, bifunctional dyes are the ones which have two different reactive groups. They can be homo-bifunctional like this, both are vinyl sulfone, or they can be hetero-bifunctional, which could be, one could be triazenyl, the other could be vinyl sulfone, or any other reactive group which you make. So, those will be called the bifunctional reactive dyes. And as a percentage, if you look at fixation, they get exhausted well, and in the dye bath printing does not have that issue, and they also require higher temperature because you are choosing such type of reactive group which requires higher temperature. So, they are stable. So, they are pretty good for the printing, all these fibers. So, bifunctional dyes are good. Then the acid dyes. So, common is like anthraquinone based dyes and also azo based dyes. So, you have this group and the anthraquinone by itself as the reactive group. Sometimes people do ask, they also have solubilizing group. Direct dyes also have solubilizing group. They are also anionic in nature. These are also anionic in nature. So, sometimes people want to know what is the difference between direct dye and an acid dye. So, that difference I think you will recall whenever you go back. Try to understand what is the difference between the two types of dyes, both are anionic. Okay. And theoretically, the kind of fiber that we use these for, they will have positive charge, they have negative charge. So, they can go there as well, make ionic bond. So, they are acid dyes, they are generally organic acids, and therefore, they are the acid dyes. So, they are basically acids. So, you can actually react them alkali and you will make sodium salts, right. Other than also other than the solubilizing group as well. So, one important thing is they are applied through acidic medium. So, when you have acidic medium, so they would not have so much of a problem, but the fiber which is the substrate, wool, silk and nylon can also be any kind of nylon. So, you have wool, silk, nylon, all of them will assume a positive charge, and so anything which is negatively charged will get attracted, and so we will have various controlling mechanisms to make sure the right kind of bondings are formed. So, dye fiber interaction is ionic, wash fastness can be an issue because they are smaller molecules and ionic bonds in aqueous medium, they dissociate, ions are dissociate very easily, and so although they are good dyes, they go very nicely and get printed also very nicely, but wash fastness can be an issue. So, for dyeing anyway we use them. For printing you may like to say, well, little larger molecule, more molecular weight may be a good idea, so that the wash fastness also improves, because there is no other mechanism of fixation except making ionic bond, right, unlike reactive dyes. So, they are water soluble and they make only ionic bonds, and therefore, they can come. Okay. So, if the molecular weight becomes high, then obviously wash fastness can improve, and that is what people will like to do. and because of that you may get some advantage by using modern dyes. Okay. So, metal complex dyes which are already there, either the complex is pre-metallized, so you already made the complex as a larger molecule, or you make the complex later in some way or the other. In printing you may like to have metal complex dye rather than just a, or you have to print with a mordant first or a pad with a mordant first and then print the mordant dye, and so you can get the complex formation there. So, one of those things will have to be done, and then the advantage definitely comes the work fastness. So, for printing you may like to use metallized, pre-metallized or metal complex dyes also, in whichever manner that you want to use. So, this you should try to get the information from wherever, from your previous classes that you have learned. What is the chemistry that helps the dye in complex formation? Why any dye forms a complex? We are looking at metallized complexes here. So, what are the essential features of a modern dye, and how are the metal complex dyes different from modern dyes? So, modern dyes are there, and how the metal comes. So, modern dyes can have different mordants also, complex formation. So, you may like to check these out and keep the note with you. The next dyes, which obviously are very interesting dyes, and these dyes called basic dyes or sometimes cationic dyes. Where the dye has a positive charge in the conditions that we use them, and so they are called cationic dyes. Initially these dyes were used for cotton, cellulosic fabrics as well, using a different kind of a mordant, but mostly they are going to be used for printing acrylic fibers or fabrics. So, they are called basic dyes because they are bases. The acid dyes were called acid dyes because they are acids. Because they are bases, therefore, they can interact with an acid, all right. That is an important part. Interestingly, because of their structures, this one which has been shown, then you have triphenyl methane based cationic dyes, high tinctorial value. When tinctorial value high generally means is they can actually absorb radiation from the ultraviolet region and also radiate out in the visible region. So, actually they appear more brilliant than other dyes. So, that is the way the structure is, and so you love those colors in general, very nice. So, the similar looking dye which is similar structure, which is an acid dye, after some change it is a base, becomes a basic dye. The other structure obviously looks more brighter. Its counterpart in acid dye looks not so bright, little duller than compared to the bright one. So, high tinctorial value. So, these are also dyed from aqueous medium, and what is the pH? What is the pH of dyeing according to you? Acidic pH. So, acidic pH is required. Only in the acidic pH this group gets generated, otherwise you will not be able to dye. And because they are cationing, the anion comes from substrate which is acrylic. If somebody asks you what is the anionic part in the acrylic fiber, what is the anion in the acrylic fiber?
Acid introducing polymerization.
All right. So, during the manufacture you can either have a copolymerization which will be acidic, or based on the polymerization method your initiators, which could be sulfides, bisulfides and so on and so forth, they they remain attached at the end of the chain, and so that is how the negative group is there in the acrylic fibers. The fastness generally is good, as I mentioned some time back also. If the molecular size is high, the wash fastness will be good. As such, acrylic fabrics, if they are used, they themselves are hydrophobic in nature, and therefore the interaction with the water is not as nice as with the hydrophilic fibers. And so once the dye goes in, then the dye goes in. Of course, the temperature etc. are important. pH of course is important. As far as the printing is concerned, you have to be careful. Acrylic fibers are sensitive to heat, and so they can get yellow, and so you have to optimize the fixation conditions carefully. Light fastness of these dyes is also good. Acrylic fibers being hydrophobic, they have less of moisture, but the bond is ionic, and so the radiation energy which is absorbed by the dye and the chromophore is, the dye actually is able to transfer the energy to the fiber and remains safe. And so light fastness of these dyes on cationic dyes on acrylic fibers is also pretty good. So you may note down from somewhere what is called a tinctorial value, why the basic dyes have high tinctorial value, learn a little more about it and keep it in your notes. Dispersed dyes, as the name suggests, they are dispersed in solution, and so they are not water soluble. So compared to the previous one, this is the major difference that we see. And you can see in a dye molecular example that is there is no solubilizing group. But they could be smaller molecules, but not water soluble, so they remain in particulate form. Whenever a situation comes when it is not water soluble, it is not soluble, then the molecules like to come together, and that is the way thermodynamic works. So they like each other and you get particulates matter. But it is not a zero solubility, it is a limited solubility, because they are called dyes. If they were absolutely insoluble, then they would be pigments, right. So in water they have solubility, but very less solubility, and this is the whole trick, that the most the dye remains in particulate form, small amount of dye get dissolved, like in a printing the total amount of water available is also very less, but it gets dissolved. Of course, temperature and solubility are related. So if you have higher temperature, solubility will be more of a dispersed dye, even within in the aqueous medium also. And so once it is in molecular form, it then diffuses in. And they have to be applied on substrates which are hydrophobic, relatively more hydrophobic. And so the name comes polyester as far as the textile people are concerned. So these dyes originally were made, synthesized much before the polyester came into the market, because we had acetate fibers which was not able to take and could not be dyed and printed with the conventional dye that were available. So they had to think about. So the structure, architecture of the molecule has changed with over the period. But when the polyester came, the dye is just made for them. Polyester is hydrophobic, the dye is hydrophobic, the bond is pretty nice, the wash fastness should not have any problem, and so it was good. They can be dyed and printed onto acrylic. They can also be printed on nylon, right. But generally we find that it is the polyester which is this major substrate for printing with dispersed dyes. With nylon there has been one issue that the glass transition temperature of a nylon fiber or fabric in water goes down and goes below room temperature. In a dry state, the glass transition temperature is close to 70 or 80 degrees, but when you put it in water, the glass transition temperature goes down, and what it means is there is a lot of mobility at room temperature and when you wash. And so the wash fastness of the same dye on a nylon is not good, although it is supposed to be not water soluble, but that is one. It can be dyed and printed onto acrylic, but not very popular because the tinctorial value of these dyes is not as bright as the cationic dyes on acrylic, and so the preference obviously is towards the cationic dye rather than the dispersed dye. Difficult to dye, but polypropylene can also be dyed with and printed with also dispersed dyes, but you have to adjust.
So can we print polyester with dispersed?
Can we print polyester with dispersed? Of course.
So what method is used?
Any methods, all kinds of methods can be used. All you have to do is the fixation condition. The fixation condition could be dry heat, superheated steam, and such type of things. So at temperatures which are higher, polyester is very responsive, and so the dye diffuses. You have thermosol methods also, so you can use different fixation techniques, but it will, once it goes in, it just goes in and you will be happy. So dispersed polyester combination is one of the best combinations that you have. The wash fastness,
CDPP can be printed with dispersed dyes and basic dyes. Means cationic dyeable polyester we can dye with basic dyes, but similar as we can use in printing.
so the cationic dyeable polyester is a different polyester. So your aim is to dye and print with a different type of a dye and not disperse. If you make it very ionic, then there will be issues of affinities. Okay. So we are looking at the normal polyester, which is the 90% of the substrate that you see anywhere in the market. So that is the major thing. The cationic dyeable percentage wise will be hardly any. You can make it, and of course then you will take the cationic dye, that is your preference. But if you want to dye a cationic dyeable polyester with a dispersed dye, you may be able to dye and print, but what is the point? Dispersed dye can just go very easily on a polyester. Why do you want to modify the polyester and then dye with a dispersed dye? That is costly also. So where wash fastness should not be a problem, light fastness depends on the molecular structure, there is no other way. So depends on which type of a molecule, the fastness will be determined. Perspiration fastness also does not have so much of effect. Rubbing is not an issue because it does not become particulate as such, goes in unless and until something is as a particulate gets deposited on the surface. In case that happens, then you will have to do some post treatment to remove those particles, otherwise no problem. But new problem is there with these dye, which is called the sublimation, which the other dyes did not have. The new sublimation issues are there. So, these dyes can sublime. So, if temperatures are suitable, you can say the shade is changing, or that is not even a problem. Dye from one gets migrated to some other portion where you did not want it. Even storage, high temperature storing, if suppose is there. So, that becomes a problem. Sublimation fastness, the new fastness which has to be checked on the dispersed dyes.
Sublimation also hinders the design.
So, they've defined now the dyes based on the molecular weight, high energy, medium energy and low energy dyes. So, if you actually are printing with the low energy dyes, then you have a more sublimation issue. If you are really looking at fastness, better fastness, then you are looking at high molecular weight, which is high energy dyes. That means you require higher energy for sublimation, and so they will not sublime. So, that selection has to be made. So, whenever you want to do printing, the data sheet provided by the dye manufacturer becomes your one of the first guidelines to choose the dye, because you do not want to have all problems that are related. So, it would not have wash fastness, sublimation fastness can be an issue. Azoic colors, well, these are formed in C2, that means on the substrate itself, and one of the reason is these dyes or colors are also not water soluble. So, you have two components, one is called a base and the other is called an naphthol, and so you mix them in a right way, in right condition, suddenly the azo group generates. Okay. So, chromophore is an azo group, and this generates when the diazotized base is reacted with an naphthol. All right. So, affinity of a naphthol comes in issue. So, what kind of a naphthol you want? But this is a very interesting thing to learn and see, is that same naphthol can give different colors with different bases, and same base can give different colors with different naphthols. And so, one of the easiest way to synthesize a molecule, the azo group synthesis is easy. But how do we print? If you remember dyeing, what you were doing in dyeing? You had to diazotize the base to make it salt, and the temperatures have to be kept around 5 degrees or below, and the whole process therefore is a tough process. And how do we print that? So, but they started modified diazonium salts, which could be stabilized so that they can be stored as it is, and you dissolve them directly in water and use, you do not have to diazotize. So, such type of things will have to be used for printing purposes. You can pad through a naphthol and then do the printing with a stabilized salt and then go for a fixation. Cotton, of course, cellulose, and is of course the kind of substrate which generally will be used for this these type of colors. Because the reaction is so quick, it is actually spontaneous. The color development is so spontaneous. So, much before you say I am fixing, the color is there, right. You can dry it. You have to be very careful in washing, of course, because all the things that you have done you have to remove, but the color develops. So, people have used various kinds of technique like spray, you pad through a naphthol and then spray different bases, and you get all kinds of multicolored effects on the fabrics, because it is so quick. So, without even a paste, that is the interesting, you can have a paste and print the way you want to print, but you can have a solution and through which also you can spray and get some kind of design which you may like, which are quite interesting. Fastness, rubbing fastness is the only thing which you should be worried about. wet and dry both. Otherwise, they are water insoluble compounds. So, if done nicely, the padding is nice, the temperatures and conditions are good, the wash fastener should not have a problem. So, what is the difference between azo dyes and azoic colors? The azoic colors are formed in situ and azo dyes are formed somewhere else, and azo dyes can be disperse, reactive, direct, all classes you can have. Within this printing, one set of colors is called illuminating colors. Illuminating colors are for the discharge style of printing. So, you have a background which is the fabric has been dyed with some dye and we want to discharge that dye. So, that is fine, you use your reducing agents to discharge the dye from the portions that you have. So, you can get a discharge area which would be hopefully white, but if you want colored discharge, in that case you got to choose some colors which are not dischargeable or difficult to discharge. In the conditions that you use, a very strong condition, everything can be discharged, but that time your fabric also may get damaged. But in a reducing environment that we actually want to discharge, so there are colors, for example, cationic dyes, anthracnone based dyes, they do not very easily get discharged. So, the triphenyl methane based dyes are highly non-dischargeable. And so, if you in your paste, discharge paste, if you use them, then you can get color discharge as well, right. So, you have this thing which normally we have not been talking in the condition in the context of dyeing, but in the conductor printing we do have the illuminating colors. Then there are pigments. In printing, they are very helpful, particularly if you have blends. Dyeing of blends also is difficult. Printing of blend is not less difficult. Two different fibers wanting two different dyes, and in case your fibers are not of the same chemical structure, then you got to have two different types of dyes, two different types of conditions to be used for fixation, just different. But if you have pigment, they do not like any fiber, they have nothing to do with the fiber. So, they can be printed on any kind of a blend. Of course, they can be printed on single fiber fabrics also. So, how do we print? Obviously, we have the same way, you have a paste and then you got to have some kind of a binding system. So, film has to be formed, and once you make a film, is the film and the fastness of the film which determines how fast the pigments prints will be. Can the same compound be called a dye or a pigment? Surely, anything which does not go at a molecular level can be pigment, and you can use them. But of course, there are specially designed pigments for doing certain things, because when you add something else on the surface of a fabric, then the third component also has to be handled from the point of durability. So, that is the only reason why somebody will still like to have dyes for printing rather than just pigments for printing, right. But these days, and one of the reasons was also the binder, it makes a film, and if it is a stiff film, then the handle etc. issues can come, but these days a lot of research has gone into making flexible films, very, very flexible films. Some of the chemistry of pigments, like azo based pigments are there, which could give you yellows, oranges, reds quite a lot. That is the kind of range that you can get. The naphthalene based, anthraquinone based, and there are two other interesting series, which is perylene based pigments and the quinacridone based pigments. They are very fast and very brilliant. They give oranges, reds and violets, so range is pretty good. Then there are phthalocyanine derivatives which have got some metal like copper. So, copper based phthalocyanine derivatives, if you remember, you had direct dyes also based on phthalocyanine derivatives. Blues and greens can be obtained using phthalocyanine. So, they are beautiful blues, and so you have a range of oranges and reds and violets also. Just an example of one or two. So, this, so that you remember, there is a molecule like this also, perylene tetracarboxylic dianhydride. So, if it was a carboxylic acid, it could be hydrophilic, and anhydride is obviously less hydrophilic. So, it is going towards thing, and no effort is being made to increase substantivity. So, this is the kind of a molecule that would be there, but of course, you can keep changing, add a nitro or a chloro or all kinds of things can be added. So, you can see there is a anhydride on this side and there is a anhydride on this side. So, interesting type of a chemistry, perylene. So, you have tetracarboxylic acid, carboxylic 1, carboxylic 2, one anhydride, carboxylic 3, carboxylic 4, another anhydride. So, quinacridone group of things give generally yellowish red to violet kind of shades they can give, and this is an interesting molecule. You are quite familiar with anthraquinones and so on and so forth, but a slightly different chemistry. So, you have almost 5 aromatic rings connected together, and of course, there is this one part of it. So, you have a carbonyl group which makes this acridone, and so you have large number of pigments based on this as well. And you know, pigments are not just used for textiles, they are used for paints, plastics, everything. So, one of the advantages sometimes is that you can go for little high temperatures like a molten material and you can add it, nothing will happen to this. Stability. If you have like a dispersed dye you want to use in, let us say, molten polyester, at that temperature you might find it's all subliming, you know. So, it's not easy to get to that type of situation. So, one always has to choose things. So, pigments are from this kind of range as well. So, this one interesting compound, this you must have seen, this is the copper phthalocyanine, all right. Beautiful blue it gives. Almost turquoise, and so this type of shade is not very easy to obtain, and so this can be used as a pigment. There are no solubilizing group here, there is nothing there, you can use this as a pigment. But if you add chlorine all over, look how many chlorines have been added. So, only at one portion it appears there is no chlorine, everywhere there is chlorine. unless and until somebody says you can't use chlorine compounds because they are not environmental friendly. So, you may not use it, but it gives green, from blue to green. A similar compound, just a change in a beautiful green it gives. And there are a large number of inorganic pigments also. Some of them can be used for textile printing also, but generally they are used for paints, ceramics, glass, and high temperature resistant. You can fuse them, melt the glass and insert them. Various techniques people use. All the churches, old churches that you see, all the colored glasses all over the place. So, inorganic compounds are used the maximum in ceramics and so forth. So, pigment are not generally sold as powders. Dyes are available in powders. For example, then you dissolve them with a wetting agent and make a paste and do everything else. And here, because this process may be little difficult, and so the chemical manufacturers are supplying emulsions. The particle size you can see is quite small, right? 0.03 to 0.5 micrometers, okay? So, that is the micron actually, isn't it? What is the diameter of fiber? A normal textile fiber, approximate? Generally, a polyester fiber available, approximate diameter. Rough, you do not have to be exact because all diameters are different. In terms of microns?
50 microns.
50 microns, quite coarse fiber like wool, but polyesters could be 10 microns and so on and so forth. So, what is important is the size of this particle has to be less than that, although you are not looking at any diffusion, the particle will not settle on diffuse. But if there is a large particle, first of all the rubbing fastness will be a problem, you will see something sticking on the fabric. This will not actually be seen as if something extra is there. Naked eye will not be able to see the particle. You do not want to actually see, oh, there are a lot of particles here. So, it will look like this very uniformly printed system. So, as I said, aqueous pigment paste, dispersion medium generally is obviously water, very easy to evaporate later after the whole process has been done. Surfactants which are used generally would have an HLB, you understand HLB? Hydrophilic lyophilic balance of a molecule should be over 10. Normally non-ionic dispersing agents are used for making emulsion. They are based on ethylene oxide condensates with various alcohol series which could be there. So, this is what actually makes it, the balance from this carbon and the oxygen or ethylene oxide groups. So, their balancing has to be done. Generally available as 20% solids, okay. So, rest is whatever, water mainly. So, this HLB in some way or the other has to be balanced. So, HLB value of non-ionic surfactants, Griffin had defined the range from 0 to 20. There are other ways of measuring HLB also, but this is one of the ways. So, 0 to 20, 0 is more lyophilic obviously and 20 is very hydrophilic. and what it means is can be calculated 20 multiplied by mH over m, and what are these? mH is the molecular mass of the hydrophilic portion and m is the molecular mass of the whole molecule. So, the ratio of this multiplied by 20. So, you ethylene oxide you will control, the hydrophobic part you will control as the mass is concerned, and the balance you have to keep. So, less than 10 if it is there, they are lipid soluble, that is they are soluble in oil and so on and so forth, more soluble, and if they are more than 10 they are more water soluble. So, obviously you will be using for our purposes water soluble surface active agents. Okay. So, binder is required because pigment does not have any affinity for fiber. Therefore, we said blends also no problem, binary or a tertiary, whichever blend that you want you can use them. And so, you require a binder. It is the binder which is more important as far as this is concerned. Color of course comes from there. And these binders are also polymeric substances, or they are pre-polymers which can be polymerized during curing. So, you have a pad dry cure sequence, pad print cure sequence, not pad actually sorry, print, dry and cure. So, a print, dry, cure sequence. So, the curing, during curing the reaction and polymerization will take place. So, you will have obviously some catalyst there to help it out, and are also sold as dispersions. So, you have a pigment dispersion, you have a binder dispersion, they can all be mixed very easily, and then you got to have a thickener. So, some of the monomers that are used for making binders are vinyl chloride, okay. So, unsaturated acrylic based, acrylonitrile based, and vinyl ether, styrene, butadiene. These kind of monomers can be used along with each other or otherwise to get to some binder which will give relatively more softer film. That means the glass transition temperature of the binder film should be very low. If the glass transition is high, it will become stiffer. If the glass transition temperature is low, so that is the calculation that you have to do, that is the manipulation that you have to do. The binder manufacturers, the printer does not do anything, it just uses them. But obviously there is a chemistry involved, so part of the chemistry is not bad idea to recall. So, today we stop here. We have learned something about dyes and pigments that can be used for printing textiles, different kinds. Next time we will see whether we talk more about thickening agents and things, and before we take some other topic. Thank you.